Okay, this question is called chess tournament. It says a chess tournament has 2 to the n players with skills 1 is more than 2, 2 is more than, so in this case 3, all the way down to the last player is less than the second to last player in terms of skill. Or second to last player is more than the last player. It is organized as a knockout tournament so that after each round, only the winner proceeds to the next round. Except for the final, opponents in each round are drawn at random. Let's also assume that when 2 players meet in a game, the players with better skills always wins. What's the probability that players 1 and 2 will meet in the final? So for players 1 and 2 to meet in the final, okay, it means that they did not meet in every other round. That's one way to imagine this question. The chance that the players 1 and 2 meet in the final is a chance that they didn't meet in all the other rounds. So let's look at tournament. This advances. They play. And there's the final. The chance that players 1 and 2 meet here is the chance that they didn't meet here. That's round 1, that's round 2, and that's round 3. For them to meet in round 3, it means they did not meet in round 1 and they did not meet in round 2. What's the chance they did not meet in round 1? Well, in this case, with the example we're showing, there's 8 players. Okay, let's say I'm player 1 here. What's the chance that I did not meet player 2 in round 1? Well, let's say this is player 2, right? What's the chance I don't meet him in round 1? Well, there's 7 options now because I can't meet myself. So, and then we're saying what's the chance that I don't meet him? It's 1 minus chance I meet him, which is 1 out of 7. Because I'm saying there's 7 options left. What's the chance that I meet this person out of 7? 1 minus 1 over 7 is 7 over 7 minus 1 over 7, which equals 6 over 7. Right? And so generally, so we're saying also like, okay, the chance that I meet him or him or him or her or him, there are 6 options out of 7. Same thing. Okay. Generally, we're saying for that, that's for like for n equals 3, right? If n equals 3, there's 3 rounds. What if there's n rounds, right? Well, then that means there is 2 to the n players. Again, I can't play against myself, so there's one less option now. And then we're saying the chance that I meet player 2 is 1 out of that. The chance that I don't meet them is 1 minus all of that. So it's 2 to the n minus 1 over 2 to the n minus 1 minus 1 over 2 to the n minus 1 equals 2 to the n minus 2 over 2 to the n minus 1. Nice. That's the chance that player 1 and 2 do not meet in round 1. What's the chance they don't meet in round 2? Well, in this case, they didn't meet in round 1. We're assuming that. Now, what's the chance that they don't meet in round 1 and they don't meet in round 2? Okay, well, assuming they did not meet in round 1, what's the chance they did not meet in round 2? Well, they didn't meet in round 1, so there's 4 players now. And that's player 1. Okay. And the brackets are randomized each round. So let's say that if this player goes here, you're saying, oh, well, if they end up here, now they will never meet in round 2. But we're saying it's randomized each round. Each round they're drawn at random. Okay. Well, the chance they don't meet here is 2 out of 3 options. Same thing as the 6 out of 7, except instead of n equals 3, we're saying n equals 2 for round 2. So for them to not meet in round 2, it's now there's 2 to the n minus 1 options because half the players were eliminated. And I can't be matched with myself, so subtract that by 1. So 2 to the n minus 1 is half of 2 to the n, just so you imagine that. Because there's 1 less 2 being multiplied together to get 2 to the n. So it's half of that. Half the players remaining. I can't match with myself, so 1 less option. That's the denominator. And then again, we saw if we do the whole thing we did here, we will get all the options minus 2 as the chance that I will not match with player 2 as player 1 in round 2. Okay, let's do this one more time for round 3. Okay, so here we're out of round because this example was too small. But if you imagine round 3, it's gonna be the same thing. Half the players get eliminated. So 2 to the n minus 2, because 2 to the n minus 2 is half of 2 to the n minus 1. So, let's me for later. So then there's 2 to the n minus 2 minus 1 options. And then there's 2 to the n minus 2 is a chance that I do not meet player 2 as player 1 in round 3 of an end round tournament. Okay, nice. So, but you just do this all the way down. You keep doing this until the second to last round. And in that round, there's going to only be 4 players, right? This is the last round. No matter what you do, you get to the second to last round, where the last round is going to have 2 players left. The round before that will have 4 players left. So in that round, there's 4 players. So there's 2 to the 3 minus 1 minus 2 over 2 to the 3 minus 1. Wait, there's 2 squared. I don't know why I'm doing 3 minus 1. 2 squared because there's 4 options. When there's 4 options, you can't match with yourself, so there's going to be 3 left. And then, again, here, what we did here, you'll get minus 2. So then, that's just 2 out of 3. We can keep this part as 2 squared minus 1. Okay. So, if we said the first round 1 was this. They don't meet in round 1. 2 to the n minus 2 over 2 to the n minus 1. Given they did not meet in round 1, the chance that it did not meet in round 2 is 2 to the n minus 2 over 2 to the n minus 2 minus 1. And then, sorry, minus 1 here. That was for round 2. This is round 3. Times 2 to the n minus 2 over 2 to the n minus 1. And then all the way down until 2 over, you can call it 3. Or just call it 2 squared minus 1. Doesn't matter. Now, I'm going to erase all this for now. This is in the way. From earlier solving. Okay. So, if you notice, if you factor out a 2 from here, what do you get? 2 to the n minus 2. You factor out a 2, you get 2 to the n minus 1. Because you factor out a 2 from here, you have 1 less 2, so out of n, so minus 1. And then 2, factor out a 2 from that, you get a 1, obviously. Okay, so then this becomes what we have here, 2 to the n minus 1. If you notice, now, these two are the same, so they can be canceled out. But hold on, if you do that for the first time, then you can do that the next round as well, factor out 2. Then these will cancel. And then these. And then these. All the way down, basically, all the ones you don't see as well will cancel out. The numerators and the denominators across. Just to show that. Do this one as well. 2 to the n minus 1 minus 2. You factor out a 2 from that, you get 2. 2 to the n minus 2 minus 1. Wait. Yeah, sorry. This is, yeah, that's right, but this is going to be a 2 as well here. Yeah. So then you see that this can become that 2 to the n minus 2 minus 1. And also these will cancel, right? This will apply for all the terms going down. So this can't. Let me make sure I'm showing you what cancels exactly. I'm saying this cancels and this cancels. This cancels and this cancels. But notice that the two remains. And then this will cancel with this and this with this, and then like this with this. What remains is the 2, the 2, the 2, a 2, a 2, a 2, and a 2. And also, this remains 2. How many 2's do we have in the numerator? We're saying for all n minus 1 rounds, right? Because if they're saying they don't meet in all other n minus 1 rounds, they will meet in the final round. So there is 2 being multiplied by itself n minus 1 times. So it's 2 to the n minus 1 over, and this remains 2. This remains 2 to the n minus 1. So this one is in the exponent and this one side by side, the minus 1s. And that's the answer. You can also solve this in a more easy way, conceptually. If you have like the tournament style game again, right? They play, and they play, all the way up to like here, where they play. Even though I already said that the bracket style is not applicable fully because they didn't mean, let's say like we draw the brackets out, and then player 1 is here, player 2 is here. Now, no matter what happens, they will not play each other because in this case, right? But we said every round is random. So like you could draw like this and then it'll shift around because it's random every time. So, but despite it being random every time, you will still get some sort of bracket style. Okay, so let's say like if you have 8 players, 1 through 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm saying that if player 1 and 2 play against each other and one wins, I'm saying like 1's the highest rank in this case and 2's the best, second best. 1 and 2 play, 3 and 4 play, 3 wins. 5 and 6 play, 5 wins. 7 and 8 play, 7 wins. Now it doesn't have to be 1 versus 3 anymore. It can still be 1 versus 5 and 3 versus 7, right? But if, I'm saying that's how it is, 3 versus 5, it can still be like 1 versus 3, but it can also be 1 versus 5. That means that we just drew this part wrong. If it actually ends up being 1 versus 5, then that means the actual layout of this first 8 was 2, 3, 4, 5, 6, 7, 8. It was 1, 2, 5, 6, 3, 4, 7, 8. 1 and 2 play, 1 wins. 5 and 6 play, 5 wins. So even though it can be randomized, the initial drawing you draw can change based on what actually happens. So even though it sounds like you cannot have the bracket style apply here, you actually can. So, assuming there's a bracket style tournament, the chance that player 1 and 2, this is player 1 and that's player 2, meet in the final is the chance that the bracket style tournament you have is one such that if you divide this in half, right? Your bracket style in half. If you have player 1 here and player 2 anywhere in this other half, they will always meet in the final because player 2 beats everybody else and player 1 beats everybody else, right? Player 2 will beat everyone besides player 1. So if they're in separate halves and they never encounter, then they will meet in the final because player 2 is going to just like win, get to here. Player 1 will beat everybody, so they'll win, and get to here. So to solve this question, you can ask yourself, what's the chance that they will not meet, or they will not be in the same half in the bracket? Well, let's say there's n options here, or 2 to the n, sorry. Player 1 gets placed somewhere, right, in one of the halves. What's the chance that player 2 is in the other half? Well, if player 1 gets placed somewhere, and there's 2 to the n players, then there is 2 to the n minus 1 slots left to fill. Imagine there's slots. Player 1 filled 1 slot. How many slots are left? It's 2 to the n, number of players, minus 1, because the 1 slot is filled out of 2 to the n slots. That's the denominator. And we're saying the chance that player 2 is in the other half. So player 1 gets placed in the sum half, this one. We're saying the chance that the player 2 is in this other half. If we're saying this 2 to the n, then this half is considered 2 to the n minus 1, because half, right? 1 less 2, so the exponent gets down but shifted by 1. And this half is 2 to the n minus 1. So then you say, well, then the chances that they're in this half is just here, this 2 to the n minus 1. So the answer is the same. We got the answer here. We got the answer here. This one is just way more easy to compute without anywhere near the same amount of math, right? But yeah, that's how you solve this question. It's a very classic question in the quant, like Greenbook probability stuff. So it's important to understand this question.